This is a tutorial on the document to factor. So we'll go through the PowerPoint first, and then we'll talk about some concepts on document to factor. Then we will be doing a few labs to get you guys prepared to actually train the model and know what's going on during the model when it's predicting different words or paragraph in document to factor, as you guys should have some knowledge on document to factor. So why do we need document to factor? So data mining, it needs to handle huge amount of data. So it's impossible for us to actually process all data word by words or letter by letter, because just over the internet, if you look in Reddit or any other website, there are millions of text being put on there nearly every single second. So if we are just using like an algorithm or some sort of trimming method that we use, even to trim out some meaningless symbols or emojis that during texting or on forums, it's still nearly impossible to handle that huge amount of information. So we need a good AI model that can help bring down all the workload there. So a good AI model, what does it mean? What is defined as good or bad is all by human. So when we look into a good AI model, as we said here, a good AI model is defined that it's being able to give out useful information that the user or developer can further use that information to analysis the correlation between words and syntax and context that is actually useful, that we can know if maybe a certain sentiment is being put on, is the user happy or not, is he having a bad day or a good day, is he having a strong feeling on certain things, so blah blah blah, etc. Maybe in a show after he has went to, if that guy actually like it or not, those kind of stuff. Just using a algorithm is actually pretty much impossible to do due to the huge amount of words we have to process. But with an AI model, we can actually trim that down by only giving out the most useful information, such as the word that appear the most and word that are actually correlated with sentiment of the user or the guy whoever posts those comments on the internet. So it takes a lot of times and it's slow if we are doing it by the traditional way. So that's what takes in the time for document to factor to be used here. So it saves time, and it is only dealing with integer and flow when it's actually predicting in the AI, instead of the traditional method where we are still actually processing all those string. That because when in computer science, when we're dealing with integer and float, it's a lot faster, because even if we look into the computer, what is actually inside, all those string is actually stored in a data format of integer and float anyway. It's stored in bits. So document to factor already converted all those words into integer and float, which will save us a lot of time. So this is why we want to actually use document to factor. This is the idea that I'm just giving you. You can think about it a little bit more. And so we're going to just talk about straightly, we're going to go into how we actually develop the document to factor model. So I'm not going to the details. So this is the process of developing the document to factor model. So in the next slide here, we're just talking about how the actual works that is being done in the document factor model. So before the AI actually learned the word, it factorized words. Why this is important that I have to mention, because this is a very essential concept that we all should know before we actually train a document to factor model, because this is critical that for data scientists or anyone who's related to the work in AI to know the basics, so that when he's messing around and twisting the hyperparameters, he knows that what kind of thing is actually happening within the AI model. So actually when it's training, it's vectorizing the words. So some people might be wondering, oh, why is that learning rate have to be adjusted? Why is that not working? Why is a validation accuracy low, but we're having a high training accuracy? So people do not understand fully, and then they start going to all those training of AI model without actually knowing some essential concept. And that's what happened all the time in the industry I've seen. So it's actually pretty important to just understand some of the basics, not all, but some we should actually all know. So when you're training and you're tuning with the model, you actually know what's going on and what's going wrong on the model layer. So in the more inner layer, you know what's actually going on here. So assume there is n unique words, a matrix of 1 times n with one hot encoding. So here you can see the quick brown fox jumps over the lazy dog. So brown will be represented as 001, 000, because is the third word in this sentence, and there is the first word, so the 1 will be put on in the array here. So every time when we are actually looking into this sentence, the factorizing process, what it does is that it will take all the words in the sentence that you have trimmed it by space. So the quick brown fox jumps, which is a different word. So jumps is a different word than jump, right? It's not equal with jump here. So every time you see a new word, what it does is that it take that new word in, and then it build a one encoding matrix that is shown here, a one hot encoding matrix. So one hot encoding actually means that there's only one being presented here, and the rest is 0. You can have like 2 1 here, and that's not considered one encoding. So that's what it means by one hot encoding. So it's a 1 here, and it's a 1 here for brown. So basically it creates an array here of 9 bits with 1 and 0s, because we have obviously 9 words here in this sentence. The quick brown fox jumps over the lazy dog. So we have 9 bit for storing the information. So for it create simply a storage space for each unique word we have C in the lines of words. So if you have another sentence, for example, the boy jumped over me, simple as that. So the will not be created with a new storage space, because we already got the with a capital T in the array here. So boy will actually create another storage space. So jump will also create another storage space, because we already got jumps. We just got jumps here, but we don't have jump without the S here. And over is already here in the last sentence, and me will be creating another storage space. So instead of having 1, 2, 3, 4, 5, 6, 7, 8, 9. We will have one for the boy that does not exist here, another one for the jump, not here, and for me. So we will have a total of 3 more storage for this sentence. So if we are putting these two sentences together combined and training these two, then the AI will be actually having all these bits stored in an array before it trained, because we have a total of 12 unique words in this paragraph. So if you have a paragraph with thousands of words, all those unique words will be considered one place in the array. And we'll actually process the text and we save it. So here you can see the line of code is being run. So we process the result text by removing just special characters. So we ignore it because during the training or even the running of the code, if we don't remove special characters like some emoji, then we will actually have issues that you will bring in errors, because Python cannot recognize all different characters that is not being directly mapped in Python. You might be able to still work it out somehow, because maybe you have installed some other packages that handle special characters, but I will suggest you to remove it anyway, because special characters usually doesn't do much. But anyway, so that's pretty much it.